This is a podcast for Year 13 AS1 and it's the past paper questions on EMF and internal resistance. So they're from 2004 to 2009. Okay, the first question here is from Jun03 and this is a very common question. In fact, in the 6 years of papers, it appears 5 times, so it's a good idea to learn off a good definition of this. And define electromotive force, or EMF, of a battery. So EMF is the energy changed to electrical energy per unit charge on passing through either the battery or cell or power source. I'm just going to write passing through a battery. And that's a good enough definition there. That should get you your mark. Explain why the potential difference across the terminals of a battery depends on the current it is delivering to an external load resistor. So there's 3 marks here, so we're going to try and get 3 points. So I'm just going to use wee bullet points. The first one I'm going to write down, well, the battery has got an internal resistance. And so that's going to be a problem. Because not all of the EMF available across the battery is going to be available to the load that's going to be connected. So the current through the battery causes there to be a potential difference drop across the internal resistance. So once the current starts to flow through the battery, then some of the voltage or potential difference is dropped across the internal resistance and the rest is dropped across the load resistor. And therefore, so the potential difference is less than the EMF. Part B, there's a current of 3.2 amps in a metal wire. Name the charge carriers responsible for the transport of charge along the wire. So it is, of course, electrons, and the word electricity comes from that.